Welcome back everyone. In the last session we have seen few questions from exercise 6.3. We completed question number 5, 6, 7 and 8. Now in today's session we are going to do question number 9 and 10 of exercise 6.3. So we hope you all remember that we are using similarity rules. There are three similarity rules, that is triple S, SAS and double AA similarity, and this AA is the mostly used similarity rule in this exercise. Okay, mostly we are using AA similarity, that is if two angles of one triangle are equals to corresponding two angles of another triangle, then they are similar. Okay, this we did many questions in the last session. Now let's see question number 9 and 10 in today's session, by which rule we can prove this too. So in question number 9 it's given that ABC and AMP, okay, you can see the figure here, ABC and AMP, okay, these two are right triangles. Okay, ABC is right angled at B and AMP is right angled at M. So these two are right angled triangles, right angled at B and M. We have to prove that this triangle ABC is similar to triangle AMP. Okay, very easily we can prove. Let's have a look. So let me tell you the steps which we'll use. So in triangle ABC you can see angle B is 90 and in triangle AMP angle M is 90. Okay, so ABC angle ABC is equals to AMP clearly because it is 90, and in ABC you can see angle A we have, and in AMP also we have angle A, so angle A is common angle here, no? That's all. So we can say these two triangles are similar by AA similarity rule. So let's see how to write the steps now. So in triangle ABC and AMP, CAB, okay, CAB, we are naming angle A as CAB, and for triangle AMP it's MAP. These both are angle A named in the different way. So this angle you can even write angle A is equals to angle A also, that doesn't matter. So this is common. Okay, next, which is the right angle in both the triangles? I said you just now, ABC and AMP. Okay, angle ABC is equals to angle AMP because both are 90 degrees. So using AA similarity we said triangle ABC is similar to AMP. Now let's see the second bit of this. We have to prove that CA by PA. Okay, in this same question we have one more bit in which we have to prove CA by PA. Okay, ratio of CA by PA is equals to BC by MP. So CA by PA is equals to BC by MP. So this I can get directly from the triangles which I proved similar just now. Okay, by taking, whenever two triangles are similar, I can say that ratio of corresponding sides will be equal. Okay, the corresponding sides will be in proportion whenever two triangles. So we proved that these two triangles are similar by AA rule. So I can say the sides are in the same ratio. Okay, corresponding sides. So we'll write that step. We know that if triangles are similar, the ratio of the corresponding sides is proportional. So what are the, how to write corresponding sides? I taught you in the last session. Okay, you can write first two letters AB by AM, you can see here, is equals any order, you can go in any order, that doesn't matter. AB by AM, then second BC by MP, then last is AC by AP or CA by PA, CA by PA. Okay, so this is the way we write corresponding sides in the same ratio. Now, do we need all these three? No, we don't require all three. We need just two ratios. So I'll take the ratios which I need, that is I need CA by PA and BC by MP. So the third ratio is not required, so I'll ignore that ratio. We'll remove that ratio. So we have got the second required to prove CA by PA is equals to BC by MP from similar triangles. So whenever two triangles are similar, always remember we can write the corresponding sides in this way, okay. Now let's go to the next question. In this question also we have 2 to 3 bits. First let's see the question. CD and GH are respectively the bisectors of ACB and EGF. So CD and GH, you can see these are bisectors of ACB and EGF, these two angles, okay. You know what is the meaning of bisector, what the bisector does to an angle. Bisector divides the angle into two equal parts, okay. When CD is bisecting ACB, I can say this angle is equals to this, that is ACD will be equals to BCD, okay. Both will be equal, or I can say ACD is half of the whole, okay. Like if you have an angle of 60 degrees and if you draw a bisector, we have done this in 9th class, then this bisector divides the angle 60 into two equal parts, that is 30 degrees each, okay. So I can say this both are equal, or I can say this each one is half of the whole. Yeah, I can say 30 degrees is half of 60. Both the ways are correct, okay. So we are going to use the same steps now. So let's write what's given first, and one few more things are given. D and H lie on sides AB and FE of triangle ABC and EFG. So D and H are lying on the sides AB and FE of triangle ABC and EFG respectively. If triangle ABC is similar to FEG, this is given to us, we don't have to prove. Triangle ABC is similar to triangle FEG, already it is given to us, okay. So what do we have to prove? We have to prove that CD by GH is equals to AC by FG. CD by GH is equals to AC by FG. So I can prove this ratio is equal once if I prove these two triangles are similar, okay. Once if I prove this triangle is similar to this one, then I can write the corresponding sides are in the same ratio, okay. So let's write what's given first. Triangle ACB and EGF respectively, and CD is the bisector of ACB. So when CD is the bisector, I can say ACD is equals to BCD. These two angles are equal to half of ACB, and GH is the bisector of EGF. So we can say FGH is equals to EGH is equals to half of EGF, okay. This both the angles are half of EGF because GH is the bisector, and triangle ABC is similar to triangle FEG. This is also given to us. Now if our intention is to prove these two triangles are similar now, okay, which triangles? Triangle ACD and triangle FGH, okay. If I prove these two triangles are similar, then I can get the first step, the first RTP. So for proving these two triangles are similar, let's start the proof. So these two triangles are similar. We know that the corresponding angles of similar triangles are equal. Because triangles are similar, I can say corresponding angles are equal. So what are corresponding angles here? For taking corresponding angles also, you should see the naming. How did you name the triangle? Angle A will be equals to F, and angle C will be equals to G, the third position. Okay, C and G is in the third position, so C is equals to G, you can say. Now I need two angles, okay, at least two angles to prove two angles of this triangle and two angles of this triangle should be equal to prove that they are similar. So now A is equals to F, I have got already. C is equals to G, we have got, but C and G are not the part of ACD and FGH. Okay, the triangles which we are going to prove similar. So I'll take just half of those. Okay, that is from equation number 2. What I'll do now, let's see. Equation 2, angle C is equals to angle G, we have got. I'll make half on both the sides. Okay, I'll multiply half on both the sides. So half of C will be equals to half of G. Okay, C is equals to G we already have because triangles are similar. So I'll multiply by half. I'll do half on both the sides because half of equals are again equal, okay, by Euclid's axiom. So half of C is ACD and half of G is FGH. Okay, because these are the bisectors. So finally we have got half of C is equals to half of G, we have got. So ACD is equals to FGH. So we got what we needed. So now we can prove these two triangles are similar. Remember, A is equals to F. We had it already, we had, because triangles are similar. And we also got ACD is equals to FGH, that is from 1 and 3. So we'll use this equation 1 and 3 to prove the triangles are similar. So now you can see the colored triangles, the green and the blue colored triangles, we have to prove similar. So in these two triangles, as I said you, A is equals to F from 1 and ACD is equals to FGH. So two angles of this triangle, the green colored triangle, are equals to two angles, corresponding angles of the blue colored triangle. So we can say these two triangles are similar. Once the triangles become similar, we can write the corresponding sides. So let's write the corresponding sides of these two triangles. So CD is by GH. You can see CD by GH. We'll just write the sides which we need. Okay, that's all. CD by GH is equals to AC by the first two letters by FG. Okay, so CD by GH is equal to AC by FG. Hence it is proved. So like we proved, these parts are equal, these two triangles are similar, sorry, ACD and FGH. In the same way we can prove the other parts are also similar, like BCD and EGH. Okay, like these two are similar, these two will also be similar. In the same way we have to prove, just here we took angle A and F, in the other part we will take angle B equals to E and half of this angles. Okay, so using the same procedure, just by changing the angles, we can prove the next part which I have done here for you, that is DCB and HGE. These two triangles can also be proved similar by using the same method. Okay, so try this on your own. And the third step is the same like the first step which we already proved. Okay, there we needed ratio. Okay, here we needed the ratio, so we proved these two triangles are similar. Okay, but here we have to prove the triangles directly. Okay, so there is no difference between first and third. Same method I have used in the third one, but you must do this in exam separately because that gives you the marks. So second and third bit you can try easily by looking at the steps which I have given. Okay, these are the important questions of this exercise. See you in the next session.